In this video, I'm going to talk about enterprise network architecture option. There are multiple enterprise network architecture design options available for deploying a campus network depending on the size of the campus as well as the reliability, resiliency, availability, performance, security, and scalability. Because of that, we should know about each of these features in one design option. Let me to review some of them. For example, I'm going to first talk about the two-tier design or a collapse core. We learned about the two-tier design in the previous video. You know that smaller networks may have their departments spread across multiple floors within a building. This environment may not require a separate core network, so collapsing the core function into the distribution layer may help on cost in designing a suitable network. Here you can see we have access layer, end user and endpoint access here is available, and also as you can see we have core distribution layer. Actually this is distribution layer. This distribution layer connected to the WAN edge, to the data center or the server farm, and after that internet edge, and then network services. The combined distribution and core layer, actually this layer, provide connectivity to the WAN. Okay, means remote data centers, other branches, internet here, and network services like the wireless LAN controller, like the identity service engine, CUCM, all threat presence manager areas of the network, as well as the connections to the access layer switches. In this design, as you can see, end user or endpoints now access to each other, and after that they access to the for example WAN edge, means they can connect to the remote data center, they can connect to the remote branches or other campus network, or for cloud connectivity to cloud providers such as the for example Amazon Web Service, Microsoft Azure, and also Google Cloud Platform. Okay, also as you can see with the end user and endpoint with the distribution and core layer switch can connect to the data center, local data center, or a server room. Here we have business critical servers that serve as websites, corporate email, business application, storage, big data processing, backup services, e-commerce transaction, and so on. Also they can connect to the internet edge, okay, again for regular internet access, e-commerce connection to remote branches, remote VPN access, cloud provider connectivity, and so on. Because of that, here we can connect to the internet edge. Okay, also as you can see we have connectivity to the wireless LAN controllers, okay, the network services that we have, Cisco Identity Service Engine, Cisco Telepresence Manager, and also Cisco Unified Communication Manager. This is one type of design that we can use. As you can see here we have two distribution core layer switch for redundancy. As you can see here we have also multiple links between the core distribution layer switch to the WAN edge router and also to the other devices. Here actually we now we have redundancy for fault tolerance, for load sharing. This is the first type of design, we call it two-tier design. Let me to explain the next type of design that we have in the enterprise network architecture options. In three-tier design, we have three layers. For example, the first layer is the access layer, and the second layer is distribution layer, and the third layer is the core layers. Okay, as you can see here, the core layer connected to WAN edge, okay, and then to data center, to internet edge, and to the network services. One of the questions that we should know the answer of this question is that why we should use the three layers. Okay, multiple pairs of distribution switches are typically required for the following reason. In this video, I'm going to talk about enterprise network architecture option. There are multiple enterprise network architecture design options available for deploying a campus network depending on the size of the campus as well as the reliability, resiliency, availability, performance, security, and scalability. Because of that, we should know about each of these features in one design option. Let me to review some of them. For example, I'm going to first talk about the two-tier design or a collapse core. We learned about the two-tier design in the previous video. You know that smaller networks may have their departments spread across multiple floors within a building. This environment may not require a separate core network, so collapsing the core function into the distribution layer may help on cost in designing a suitable network. Here you can see we have access layer, end user and endpoint access here is available, and also as you can see we have core distribution layer. Actually this is distribution layer. This distribution layer connected to the WAN edge, to the data center or the server farm, and after that internet edge, and then network services. The combined distribution and core layer, actually this layer, provide connectivity to the WAN, okay, means remote data centers, other branches, internet right here, and network services like the wireless LAN controller, like the identity service engine, CUCM, all threat presence manager areas of the network, as well as the connections to the access layer switches. In this design, as you can see, end user or endpoints now access to each other, and after that they access to the for example WAN edge, means they can connect to the remote data center, they can connect to the remote branches or other campus network, or for cloud connectivity to cloud providers such as the for example Amazon Web Service, Microsoft Azure, and also Google Cloud Platform. Okay, also as you can see with the end user and endpoint with the distribution and core layer switch can connect to the data center, local data center, or a server room. Here we have business critical servers that serve as websites, corporate email, business application, storage, big data processing, backup services, e-commerce transaction, and so on. Also they can connect to the internet edge, okay, again for regular internet access, e-commerce, connection to remote branches, remote VPN access, cloud provider connectivity, and so on. Because of that here we can connect to the internet edge. Okay, also as you can see we have connectivity to the wireless LAN controllers, okay, the network services that we have, Cisco Identity Service Engine, Cisco Telepresence Manager, and also Cisco Unified Communication Manager. This is one type of design that we can use. As you can see here we have two distribution core layer switch for redundancy. As you can see here we have also multiple links between the core distribution layer switch to the WAN edge router and also to the other devices. Here actually we now we have redundancy for fault tolerance, for load sharing. This is the first type of design, we call it two-tier design. Let me to explain the next type of design that we have in the enterprise network architecture options. The next model is the three-tier design. In three-tier design, as you can see, we have access layer. Here we can see the access layer and also the end user endpoints, and then distribution layer and also core layer. Why we should use three-tier design? One of the most important reason is that we have more than two distribution layer switch. We need a core layer. Don't forget, when for some reason you need to use multiple distribution layer switches, and after that you will use a core layer. For example, if you have one enterprise and in your enterprise you have multiple buildings, each building maybe need its dedicated distribution layer switch. Because of that, finally we will have multiple distribution layer switch, and we can connect this distribution layer switch to each other with the core layer. Another reason for use of multiple distribution layer switch is that when the density of WAN routers, okay, or internet edge devices or data center servers and network services are growing to the point when they can affect network performance and throughput, we will use the for example distribution layer switch. Look at here, for example, for WAN edge now we have distribution layer switch. For the internet edge we have a distribution layer switch. For for network services, we have distribution layer switch. Because of that, now we have multiple distribution layer switch, and we can connect all of them together with the core layer. And finally, when geographic dispersion of the LAN switch across many buildings in a larger campus facility would require more fiber optic interconnects back to a single collapse core, we need a core layer. Actually, it can be cost effective, or it can reduce the cost. Here in this picture, you can see different places in the network. We call them the places in the network, or PIN. Okay, for example, we have WAN edge, we have data center, we have internet edge, we have network services. In WAN edge, we have distribution layer switch connected to the core, also in the internet edge, also in the network services. But in the data center now, we use a newer version of design. We call it leaf spine design. This is a little beyond the scope of our course, but let me to say that here, the most traffic is east-west traffic, and because of that, the usage of the leaf spine design can give us the better performance in compare with the hierarchical design that is suitable for the north-south traffic flows. Because of that, here we use in the data center leaf spine design, and as you can see, the switch here, these two switches connected to the core layer. Don't worry about the detail of data center now, but here it is important to say that now we use three-tier design. With this three-tier design, we have communication between the endpoints and end users with each other, and also with the WAN edge, with the data center, with the internet edge, and with the network services. This is our enterprise network architecture in the three-tier design. Alright, until now we learned about the two-tier and also three-tier model of design. Don't forget, between the access layer switch and also distribution layer switch, in each of these two models, we can use layer 2 link or layer 3 link. In the traditional network design, always we use the layer 2 switch in the access layer, and also the MLS or multi-layer switch in the distribution layer. Because of that, the link between the access layer switch and the MLS only can be layer 2. Okay, and as you can see here, we have two options for design. The first type of design is that we can restrict the VLANs to only one switch. As you can see here in the left network design, between the access layer and also between the distribution layer, the VLAN 10 restricted only to this switch, okay, and VLAN 20 restricted to other switch. Because of that, actually, because here we don't have any VLAN 10 member in this in the right switch, actually we don't have any possibility of loop. Actually, this link work only for VLAN 10, and these two links are working only for VLAN 20. Because of that, here we can see this is loop free, but the restriction is that we don't for example, assign VLAN 10 to other switches except than the, for example, first switch. If you use this model, actually, if you restrict the VLAN 10 to only one switch and VLAN 20 to only one switch, you can use the bandwidth of all of the links. Actually, STP doesn't block each of these interfaces, okay, here. But in the right scenario, as you can see, we have the loop topology. In the loop topology, VLAN 10 can be available in all access layer switch. Because of that, here now we have a loop. STP can block interfaces. Look at here, when you use the loop free design, means the VLAN 10 only is available in one switch and VLAN 20 in another switch. The link between these two distribution switch can be layer 3. Because of that, actually now we don't have any loop. Also, if we want here, we can use FHRPs or first hop redundancy protocol. You know that with the FHRP, we can use the benefit of the link with the router redundancy. FHRP is the abbreviation of first hop redundancy protocol, and we have three protocols, include the HSRP, VRRP, and GLBP. HSRP is the abbreviation of hot standby router protocol. VRRP is the abbreviation of virtual router redundancy redundancy protocol, and GLBP is the abbreviation of the gateway load balancing protocol. We can enable FHRPs between these two router or these two MLS, and because of that, when, for example, one PC as a member of VLAN 10 wants to send traffic to the for example, external networks like the other VLANs, like the internet or some other places, it can use one of the routers as the active router, and if the active router failed, it can use the other router, the standby router. In HSRP and VRRP, one router is the active router, okay, and other router is the backup router or the standby router. Because of that, actually we have only fault tolerance. But if you enable GLBP or gateway load balancing protocol, here we have the option of the load balancing. We can send traffic from both router to the outside. Okay, but when we use the loop topology, and you know that this link is blocked, for example, for VLAN 10, this link is blocked for VLAN 10, and now only we can see the one of the switches here is the active switch. Okay, actually we don't use this switch, this distribution switch. Let me to show you. Assume that here we have distribution 1. This is the distribution 1 switch, and this is the distribution 2 switch. Okay, when we use loop free, okay, it means that we have one restriction. The restriction is the VLAN 10 should be only restricted to one switch and VLAN 20 to other switch. Because of that, we don't have loop. Okay, and because of that, the STP doesn't block any interface, and for VLAN 10 we can use both of these two links, and for VLAN 20 we can use both of these two links, and the link between distribution 1 and distribution 3 is the layer 3 link. Here you can use one of the FHRPs like the HSRP, like the VRRP, like the GLBP. Okay, and you know that GLBP is the most efficient protocol because we have the option of load balancing. Actually, the computers in the VLAN 10 can use both of these distribution switches. Okay, and also here the computers in the VLAN 20 can use the distribution 1 and distribution 2. Okay, but when you use the loop topology, it means that you are propagating the VLAN 10 interfaces in multiple switches. Okay, here we will have loop. For example, the first thing that it is important for us that the link between these two switches should be layer 2 for connectivity between the VLAN 10. Okay, and after that, this two link, or for example, if the distribution 1 is the root bridge, will be blocked because this is the root bridge, and all of the interfaces connected to the root bridge are up or forwarding, and these two interfaces will be blocked. Because of that, here we cannot use the GLBP. Actually, we can use only HSRP and VRRP. Actually, here we don't have the benefits of the load balancing. Only we can use these two protocols for their fault tolerance. Look at here. Assume that we have a PC connected to the VLAN 10 of this switch. Okay, and also we have the next PC again connected to the VLAN 10 of the right switch. Here you know that we cannot use GLBP. For GLBP, this PC needs to send its traffic to both of these two distribution 1 and distribution 2, and as you can see, this link is blocked or this link is blocked. Here we can use HSRP or VRRP. Because of that, we can say about the layer 2 access layer, it is recommended when we use STP, it is recommended to use the loop free with one VLAN per access switch, and we should prevent to use the loop topology with VLAN spanning access, multiple access switch. This is only a recommendation, but in some cases maybe you need to for example, propagate the VLAN 10 interfaces between multiple switches, and in that time you can use the loop topology. But if it is possible, it is recommended to use the loop free design between the layer 2 and layer 3. Don't forget, we talk about the conditions that we have layer 2 only switch and multi-layer switch in the topology between the access and distribution. Okay, because of here we have only two options. The first option is that we use loop free design or loop topology design. Okay, but if your MLS can support your access layer switch support the multi-layer switching, here we have other options. In this design, the switch, as you can see, the access layer switch support only layer 2 switching. Because of that, we need to use layer 2 link. For designing of layer 2 links, we have two options, loop free and loop topology. Now, let me to explain the next condition that maybe we have in the access layer. We call it layer 3 access layer. Alright, in the layer 3 access layer or routed access layer switch, okay, here you can see that now we have MLS in the access layer. Okay, in the right picture you can see that we have MLS. Because of that, we can convert the interfaces of the switch to the layer 3. Actually, now we have full layer 3 capability or full layer 3 routing between the access and also distribution. Actually, here now the access layer switch is the boundary between the layer 2 and also layer 3 domain. Here you can see that layer 2, we have layer 2 access layer. This is STP based, but here we have layer 3 access layer. This is the for example layer 3 access layer. Also, let me to emphasize that when you use the layer 3 access layer, we don't need to configure any first hop redundancy protocol. Actually, FHRP is not available here because the boundary of the layer 3 is the access layer switch. Actually, the access layer switch has the complete capability of layer 3 routing. Actually, the default gateway should be configured on the access layer switch. Because of that, here first hop redundancy protocol does not require. After that, here we don't have STP. We don't need STP because you know that here we have multiple links. All of these links are layer 3 links. Because of that, here we don't have any layer 2 loop. Because of that, we don't have actually STP, and it means that all links now are forwarding, and we can use the more bandwidth that here we have. Because of that, we can say in the layer 3 access layer method, okay, we have the more bandwidth. Actually, this method increase the uplink utilization. After that, the troubleshooting is easier. You know that here we can use ping and traceroute and some other features that we have in iOS for troubleshooting. Actually, from the access layer switch, you can use ping command. You can verify the paths directly from the access layer switch then to distribution layer switch and to other devices, because here we all of these links are layer 3. And also here we have faster convergence. You know that STP does not have the, for example, fast convergence time. You need to use RSTP or rapid STP. But because between the layer 3 access layer switch and also the distribution switch, we have layer 3 links, we can use, for example, EIGRP or Enhanced Interior Gateway Routing Protocol, and also OSPF, Open Shortest Path First for routing. Because of that, we will experience the faster convergence time. Actually, it means that the network will be faster. Okay, this is the layer 3 access layers benefits. But here also we have some disadvantage. For example, you know that now the VLAN 10 should be located only in one switch. Actually, you cannot use VLAN 10 in this switch and also in other switch. Actually, in your network, if you want to spread the VLAN 10 between different switch, you cannot use the option of layer 3 access layer. Also, the implementation of this method has, for example, a higher cost. You know that here we need to use MLS switch in the access layer. Because of that, we need to pay more. Because of that, this is another disadvantage of the layer 3 access layer. You know that until now we learned about the two-tier design, actually two-tier or collapsed core, and after that 3-tier, and after that we learn about the layer 2 access layer STP base and layer 3 access layer routed access. Okay, you know that you can combine these methods together for the design of enterprise network architecture. Let me to explain the next feature, the next method that we have for enterprise network architecture. We call it simplified campus design. In simplified campus design, we use switch clustering features. For example, you know about the virtual switching system or VSS, or stacking technologies such as StackWise. In these technologies, we can convert multiple physical switch to a logical switch. Okay, you learned about them in previous courses. Because of that, actually here, as you can see, now we have a network include 2 access layer switch, okay, and 2 distribution layer switch. As you can see, we can use the VSS or virtual switching system to convert these 2 physical switch to 1 logical switch. And after that, as you can see, now we have 2 link between this access layer switch and also this VSS. Because of that, we can use Ether channel technologies or aggregation technologies. Now we have layer 2 or layer 3 multi-chassis Ether channel, okay, as you can see here and also here. And after that, if you have the option of using the stack-wise technology, you can stack-wise these 2 access switch together. Again, now we have the option of the aggregating all of the interfaces with each other, and now we have a higher bandwidth link between them. Look at here, in the first scenario, okay, in the first physical layout, you can see that the 2 distribution switch converted to 1 logical switch with VSS technology, okay. You can use only VSS. If you use only VSS, and after that here you can see, because now between this access switch and this VSS, we have 2 link. We can aggregate these 2 layer 2 or layer 3 links together. We will have multi-chassis Ether channel, one here and another here. Okay, this picture. But if you can do the stack wise or do stack this 2 access layer switch also to each other, for example here, and actually now we have 2 logical switch. The first logical switch created by the VSS technology between the distribution switch, and also the next logical switch created with the stack wise technology, okay, between the access layer switch. And now actually all of these 4 links connected to 2 logical switch. Because of that, again here you have the option of the layer 2 or layer 3 multi-chassis Ether channel. Also, let me to say that using this design approach across all the campus blocks, okay, when possible, can provide an optimized architecture that is easy to manage, resilient, and also more flexible with higher aggregated uplink bandwidth capacity. Here you can see that we use the simplified campus design. Actually, we stack the access layer switch here, and after that the distribution switch here aggregated with the VSS technology. And after that, we aggregated the links between these 2 layers, and now we have a simplified actually design. Also, as you can see, in the other places in the network, again now we are using the VSS or stacking technology. For example, between these 2 distribution layers switch, now we use VSS, and also here VSS and then VSS. And actually, as you can see, now we can aggregate all of these links. And here we have multiple benefits. One of the benefits is using a simplified design. With simplified design, actually you need to manage only single logical distribution layer, and it means that you need to waste for example less time to configure, to manage, to troubleshoot this network. It reduces the amount of time spent on ongoing provisioning and maintenance. Actually, with this simplified campus design, as you can see, we don't need to configure first hop redundancy protocol for like the HSRP, like the VRP, because the IP gateway or default IP gateway is residing only on single logical interface. For example, interface VLAN 1 of this VSS, interface VLAN 1 of this VSS, or other interfaces. Actually, here the 2 physical switches are converted to 1 logical switch, and in this 1 logical switch we have only 1 interface VLAN. Okay, after that, the other benefit is that we can say reduced STP dependence. As you can see here, we don't have any loop and we don't need to use STP, and because of that our dependence to the STP now is reduced. And actually we can use Ether channel, and you know that when you use Ether channel, actually you eliminate the need to the STP, and it is one of the benefits of the simplified campus design. After that, as you can see here, we have increased uplink utilization because we can aggregate all of the links, okay, to each other. We don't have any block link, and because of that we can say that increased uplink utilization is one of the benefits of this the network design. And after that, about the easier troubleshooting, you learn about the benefits of the troubleshooting that here we have. For example, you know that because the topology of the network from the distribution layer to the access layer is logically a hub and spoke topology, this reduces the complexity of the design and troubleshooting. And then faster convergence, again because here we have ether channel. If one link failed, other link is available or other links are available. Because of that we can say that every time the convergence is for example faster than other technologies. It is obvious. And finally, about the distributed VLANs, we can say with this type of design, VLANs can span multiple access switches without the need to block any uplinks. You know that all of these access switches, okay, are members of one logical switch. Because of that, you can configure the VLANs, okay, different VLANs in different switch, because actually they are members of one logical switch, and we don't need to, for example, block the links like the layer 2 access ports or some other things. Here you can see that with simplified campus network design, actually now we use the benefits of multiple features in one design. Alright, here we can compare the 3-tier design and also simplified campus design. In 3-tier design, we have multiple links, multiple, for example, switches, and as you can see, this is a little complex. But in the simplified campus design, we have only lower number of the logical switches and lower number of links. As you can see, the maintenance, the troubleshooting of this network is easier than the 3-tier design. Because of that, we can say if we have the option of using VSS and also stack-wise cap technologies, it is recommended to use them. The next enterprise network architecture option is the software-defined access or ST-access design. Actually, software-defined access or ST-access is the industry's first intent-based networking solution for the enterprise, built on the principles of Cisco's digital network architecture or DNA. ST-access provides automated end-to-end segmentation to separate user, device, and application traffic without redesigning the network. There are many challenges to manage enterprise networks, including manual configuration and fragmented tool offering. Manual operations are slow and error-prone, and these issues are exaggerated by constantly changing environment with more users, devices, and applications. With the growth of users and different device types accessing the network, it has become more complex to configure user credential and maintain a consistent policy across the network. Without a consistent access policy, it is difficult to maintain separate policies between wired and wireless, or to locate users and troubleshoot issues as users move around the network. Built on the principles of intent-based networking, ST-access helps organizations enable policy-based automation from the edge to the cloud. ST-access gives network architects the tools to orchestrate key business functions like onboarding, secure segmentation, IoT integration, and guest access. ST-access automates user and device policy for any application across the wireless and wired network via a single network fabric. And ST-access is a transformational shift. It allows IT to set network access in minutes for any user, device, or application without compromising on security. We will learn about the software-defined access or ST-access more than this in future, but for now we can say that one of the newest method of the enterprise network architecture is using the software-defined access or ST-access. Alright, now we know about two-tier design or collapse core, three-tier design, layer 2 axis layer STP based, layer 3 axis layer routed axis, simplified campus design, and finally software defined axis or SD axis. They are different enterprise network architectures options, and let me to say that in some cases we combine different methods, various methods with each other.